All right, let's go over the major muscle groups real quick. You're going to need this information when we get to the health-related components of fitness. We're going to talk a little bit more in depth about the muscles, but you're also going to need it when you develop your program. You need to know what major muscle groups that you're hitting. They can have a big impact on weight loss. So the more lean muscle mass you have, the more calories you burn at rest, and the more calories you burn when you're active. Let's start with the anterior muscle groups. So let's just start with the deltoid. So deltoid is broken into 3 parts, and one of the major parts is the anterior portion of the deltoid. So if you do bench press, if you do push-ups, you're going to hit or train the anterior portion of the deltoid, and that is a pushing muscle. So the biceps is more of a pulling muscle. So arm curls are a way to isolate the bicep. If you did chin-ups, that's another way to isolate the bicep. And there is a difference between chin-ups and pull-ups. So it all depends on the grip that you're using. If your palms are facing you when you're gripping the bar, that's a chin-up. So that's a way to activate that bicep along with some of the major muscle groups in the back. Here we have the pectoralis major, your pecs, your chest. So it is one of the big 3 on pushing activities. And I know we haven't talked about it yet, but the tricep would be one of those 3. We'll get to that when we get to posterior view, but if you're doing like bench press, you're doing push-ups, you're hitting the pectoralis major, anterior portion deltoid, and tricep. I'll just show it to you real quick. That's tricep. So those are compound lifts. They're going to help you put on more lean muscle mass. All right, so now let's look at rectus abdominis. And that would be like sit-ups, crunches, flutter kicks, leg raises, anything you do for your core, that's rectus abdominis. So now when you do flutter kicks, you're also hitting the hip flexors, but they're a smaller muscle group. We're not going to talk about those right now. All right, now you have quadriceps. So that's 4 muscle groups in one. Anything like lunges, squats, and that could be with weight or without. It could be with body weight. Sprinting activities, they're all going to hit quadriceps. Now I'm not giving you a comprehensive list of all the activities. I'm just giving you a rough idea. I'm trying to give you one with body weight, and I'm trying to give you one with weights, just depending on your training. So now let's flip over to the posterior side, and we'll start again with the deltoid. The deltoid is a pulling muscle, the posterior deltoid. Now we talked about the anterior portion of the deltoid, that's pushing, but the posterior portion of the deltoid is a pulling muscle, and it's a fairly large muscle group. And we'll talk about the middle portion of the deltoid when we get to abduction, adduction. And we already talked, so pulling activities would be like rows or pull-ups. And if you did triceps, it'd be push-ups. We already talked about that. Chest press, incline press, shoulder press. Any of those would work to hit your triceps. If you wanted to isolate them, you can do tricep extensions. So let's move on to the trapezius. It's a huge muscle group that anytime you do any pulling activities, you can hit the trapezius, but it's not limited to just pulling activities. So if you look here at anterior view, you can see the trapezius here, and here's the rest of the muscle group here on the back. And so it makes kind of like a diamond shaped, or I guess diamond shape would be the best way to explain it. So you can also do shrugs, and when you do shoulder press, if you shrug your shoulders at the end of that activity, it's like doing shrugs with dumbbells. Start to activate the trapezius. Now you have the latissimus dorsi down here, another huge muscle group. And anytime you do like lat pull downs, if you're using a machine, or pull-ups or chin-ups, you're hitting the latissimus dorsi. We have gluteus maximus right here. So you also have the hamstrings or biceps femoris right under it. We'll put these together. So anytime you do squats, you do lunges, you do deadlifts, both of those are going to be activated. So gluteus maximus And hamstrings are different muscles, but a lot of times you'll hit those with the same activities. If you did sprinting, you're going to hit those as well. Gastrocnemius, so like calf raises, these are your calves. Squats, lunges, calf raises, any of those would hit that area. All right, real quick, let's talk about different actions for different muscles. So we talked about the deltoid having 3 major parts and really has 3 major actions, and we'll talk about that in just a little bit once I have a better diagram. Also with the trapezius, we did the same thing where you can see it from anterior view, but it's really more of a posterior muscle unless you're doing shrugs. Superficial and deep, you have some muscles that are right underneath the skin, so most of your major muscle groups that I just mentioned would be considered superficial because you can see them. An example of a deep muscle would be like the rhomboids. So we've got the trapezius here. Underneath that, you have the rhomboids that go out to the shoulder blades. So if you've ever seen somebody on a video take a pencil and pinch it between their shoulder blades as they're doing rows, they're activating the rhomboids in that position. All right, different actions that you need to know, concentric, eccentric. So you notice here, this is the bicep muscle. And it's not just the bicep. Anytime the muscle is contracting through the movement, that is the concentric contraction of that muscle. Anytime it's elongating, so now we have the arm lowering, we're elongating the muscle, that's eccentric. And you can get strength gains just from eccentric activities. So I had a student one time that wanted to be able to do pull-ups, couldn't pull their own body weight, had that person step up on a bench where their chin was above the bar. They would step off the bench and lower themselves down, and they would do sets of 10 every time they came to class. They would do like 3 sets of 10 of just the eccentric phase. And by the end of the semester, that person was able to do 4 full pull-ups without ever attempting them. During class, I should say. And you can do that on bench press as well. So if you ever see somebody get on bench press and they have a spotter and they lower the weight, a heavier weight than they can lift, and once they start trying to push the weight away from them and they get to a sticking point, somebody helps them, that lowering is the eccentric phase, the elongating. And so what happens is the spotter helps them get through the sticking phase, and eventually by doing several reps of that and sets, they'll eventually get over that sticking point. So yes, eccentric or negative reps can help you on strength training. So here's where I wanted to talk about the middle portion of the deltoid. So if you've done some sort of lateral raise, let's just pretend this person has some dumbbells in their hand. That's abduction. So you're taking the weight away or the arm away from the body. So it's being abducted. It's been taken away. That's going to hit the middle portion of the deltoid. You're also going to hit the trapezius as well. And then you bring the weight back to you, or the arm back to the body, back towards center line. Like if we cut this person in half, brought that arm back towards center line, that is adduction. Pretend that you're adding the arm back to the body. So again, you can hit the middle portion of the deltoid and the trapezius that way. So types of muscle activities that you'll talk about or you may hear about. Isotonic would be something like push-ups or bench press. So we're pushing the muscle, the weight away from us. The muscles are contracting, but we can push at different speeds. Isometric, we're holding a static position. You see this in gymnastics. You see it in wrestling. When they get to a fixed position, like a clinch position, nobody's really moving those muscles through a range of motion. That would be isometric. But probably the best example would be somebody holding the iron cross or a position in gymnastics. That's isometric, where you just can't exceed that opposing force. You're holding a fixed position is the best way to think of it. And isokinetic, you don't see these machines too much anymore, but the speed is constant. So there's a constant speed. And there are machines out there that they used to have with air pressure. So if you started going too fast, you could only keep a consistent speed. It wouldn't allow you to go any faster, and that would be isokinetic. All right, the anatomy of muscle. This is important to understand. especially when we start talking about muscle hypertrophy and how muscles grow. So we've got the fibrils. Those are all bound together with connective tissue, and that forms a muscle fiber. The muscle fibers have connective tissue that hold all the fibrils together, and then those are collected together to form the muscle. So we're just bundling each time with connective tissue. So this white stuff you see here is connective tissue made up of collagen and elastin, and that's your tendons that are holding that stuff together, or holding the muscle to the bone. So you've got a tendinous attachment that it connects muscle to the bone. And when we talk about ligaments, we're going bone to bone. When we talk about tendons, it's that connection between muscle and bone. Just a simple common sense explanation. Connective tissue made up of collagen and elastin. Collagen are the small white fibers that provide the structural support. So think of those as the lattice work, the scaffolding. And then you have elastin, which allows the muscle to stretch out and recoil back to its normal shape. So if you looked at this stuff underneath the microscope, the collagen is going to be the little white fibers. The elastin will be yellowish in color. Think of it like elastin in your waistband. So you stretch it out and it goes back to its normal shape. Muscle hypertrophy, muscle growth. So we get that through breaking the muscle down through exercise and allowing it to heal. So we're increasing the number of myofibrils, increasing the size of the muscle fibers, which in turn increases the size of the muscle. Here's a quick breakdown of it, and this is just simple explanation. So you have your first training program, you work out, you get that breakdown of the muscle fiber, and as it heals over time, you start to get this muscle growth. If you don't train enough, you'll get atrophy. So you'll go back to that normal size muscle, but you'll still keep a lot of those myonuclei in the muscle, so it doesn't take you as long to get back. So if you've ever heard somebody say, well, once you get those results, it's not hard to get back to where you were at, well, that's what they're talking about. So we get that stem cell activating, causing that growth as well. So that's just a quick, basic explanation. When you break the muscle fibers down here, let's say this is the first training program, you may get a lot of soreness, and that's called delayed onset muscle soreness. So you get the microtrauma, and then the muscles heal back up, and because you've had all these ruptures at the microscopic level, that has to heal. The older theory was that it was lactic acid causing the pain, and that's not necessarily true. We found out that it's more of the damage that's happening at the microscopic level that's causing all the soreness. Just like a wound would heal and be sore, that's what's happening to the muscles. So this just gives you a breakdown of what the myofibrils look like all bundled together. All right, so we've got muscle fibers, and I can explain that with the chicken. So we can see two different muscle fiber types, main types, in a chicken. And this is how it was explained to me. There are more than just these two, and I'll talk to you a little bit about them. But I think this will kind of stick in your mind and help you remember it for the rest of your life. So this is a farm-raised chicken. This is not one raised in a cage, or you may not see this contrast between muscle fibers. But a farm-raised chicken can run around all day long. I mean, that's its primary means of moving around. And if you look at the leg muscle, that's why it's all dark meat. It's got a lot of blood supply to it. It's got a lot of myoglobin in it. It's what gives it that dark coloration, is all that blood supply, capillary innervation, so more blood supply getting to it. And that's a reason you can run around all day. Now, if you looked at these muscle fibers underneath a microscope compared to fast twitch, so these are slow twitch right here in the leg. If you compare them to what's up here in the breast, these are going to be much smaller because they're slow twitch. So slow twitch are type 1 fibers. You see those in endurance athletes. A lot of this has to do with your genetics, but you can change it through training. Then you have fast twitch. Now, I was just referring to the breast meat here as fast twitch. So a chicken can't fly very far. And this is all white meat. So they fly for a short distance, get fatigued, they have to stop. And that's because of the muscle fiber type they have, and plus just how they're built. But a lot of it has to do with the type of muscle fiber they have. It's all white meat. So it runs off the immediate source of ATP within it. And then once that's used up, they get fatigued. But it's big and bulky. That's the reason the breast meat is huge in size, to power those wings for a short flight, not very far. So think of that like a sprinting event. So you've got slow twitch in the legs, fast twitch in the chest, or the breast meat. And so those would be considered fast twitch glycolytic because they're all white meat. Now if this was a duck, that would be all dark meat because a duck can fly a long time. Now obviously they're built different, have a different wingspan, but it also has to do with what's powering those wings, that breast meat. So a duck can fly all the time and it has slow twitch. And that's the reason it's dark meat. So a chicken, breast meat, type 2B. And their legs are type 1. Now we have fast twitch oxidative glycolytic, a different type of muscle fiber. This is type 2A. This would be more me, right? So I do a lot of muscle endurance activities. I'm not necessarily slow twitch. I'm not necessarily fast twitch. I'm tone, and I can do push-ups and lunges and sit-ups. I can do a lot of them, right? I can do a lot of muscle endurance activities. I'm fast twitch oxidative glycolytic. And I know that not just because of my training and the way I look, but when I was in college, we did a muscle biopsy. And the majority of my muscles were fast twitch oxidative glycolytic. So I do really good in endurance events that are shorter duration than marathons. So this would be a marathon runner. So we have a Kenyan here. The Kenyans have a genetic gift because of where they lived. So in 1988, I believe that's when the Kenyans came in. Before that, endurance events were dominated by Europeans. But the Kenyans live at high altitude, and they have more mitochondria within their cells. They have more red blood cells. They have more slow twitch muscle fibers. They are built for thinner oxygen. And so they do really well because they have lived in that location for thousands of years. So they do really well. A lot of Europeans also lived at high altitude. So if you look at Austria and places like that where they have higher altitude, they did pretty good, but it wasn't the same benefit that the Kenyans were getting at their high altitude. And so they tend to dominate now endurance events. And a lot of it has to do with genetics and just where they have lived for thousands of years. And then we have sprinters. So if you look at the muscle, so we've got an Olympic sprinter versus an Olympic endurance athlete that runs marathons. And look at the muscle size, especially in the legs. I mean, look at the difference there. If this guy had all this muscle, he would not do as well as he does for those long distance events because that extra muscle is going to use up oxygen and energy that he needs to compete. And vice versa, if the sprinter has all this slow twitch, he's not going to be very fast because he's not going to have the huge motor neurons and the muscles needed to generate the power to go fast. So part of this is genetics, and the other part is training. If you get somebody that has both really good training and really good genetics, they're going to do great for their sport. All right, here's a good example of fast twitch versus slow twitch underneath the microscope. So these are slow twitch, and these are fast twitch. And look at the color difference, and even look at the size difference. So slow twitch, aerobic activities, best for aerobic activities, steady power, endurance. So your fast twitch, anaerobic, stop and go, explosive power, fatigues easily. So you would think you would need this in wrestling, when in fact you need more fast twitch oxidative glycolytic, the combination between these two. So you want some blood supply to get it. You want to be able to maintain a fair amount of resistance over, let's say, 5 minutes. but you don't need slow twitch. You still need power, but you don't need as much power as you're going to see like in sprinting and powerlifting. You need a mix of the two. So it all depends on the sport. And this is a really good way of explaining muscle fiber types, the health-related components, the time at which you need for the event, and the energy system used. So if we're talking about muscle strength, which is a health-related component we're going to get to, and that's what you want to specialize in, then you need to develop fast-twitch glycolytic muscle. That's that big, bulky muscle. Your events are going to last about 10 or 12 seconds, so like sprinting, all-out events. You're going to run off the immediate source of ATP within the muscle, so you're going to need the ATP-CP system. You're going to have huge, large motor neurons, and the events that you would probably do well in would be powerlifting and sprinting. So if you did a muscle biopsy and you saw that you had a huge percentage of fast-twitch glycolytic muscle and you didn't train, you probably need to start training for it. Muscle endurance. So this is fast-twitch oxidative glycolytic. This is me. So events that last around 1 to 3 minutes, anywhere from 1 to really 5 minutes. Right before the aerobic system really starts to kick in to supply our energy needs. Glycolysis is generating our ATP. So you have a moderate sized motor neuron. So you're getting those neural impulses to the muscles fairly quickly. It can handle a lot of electrical activity through it. Push-ups for 1 minute, push-ups for 2 minutes, wrestling, anything that requires a lot of endurance for a shorter period of time. So if you're doing a lot of cardiorespiratory training, and that's all you do, you'll probably have a higher percentage of slow twitch throughout the body. So that's type 1 fibers, greater than 5 minutes, aerobic oxidative. You're going to have a small motor neuron size because you don't need real fast, rapid contractions. So events like marathons or those elite level endurance activities where people, or those endurance events where they're running long distance like triathlons, all of that would fall under that umbrella where you need a lot more slow twitch for those events. And it's not saying you won't have a mix between those two. It all depends on genetics and how you train. So let's talk a little bit about genetics real quick. We have myself versus Arnold Schwarzenegger. We're the same height, but if you look at our genetics, let's say we're the same height, same age. Let's just pretend I'm 25 right now and Arnold's 25. If Arnold doesn't train at all, and I train and I supplement and I do everything I can to get big, I might, maybe, get a little bit bigger than him if he doesn't ever touch a weight or do any training. But if he ever touches a weight, he's just going to outperform me. He is built for his sport, and I'm not built for that sport. So genetics play a huge role in what we do in the sports that we're going to excel at. So you need to kind of have a good understanding of who you are and what events have you just naturally done well at, and that probably gives you a good idea of your genetics. So this is going to set us up for the health-related components. We'll get to muscle strength next, and then we'll move into muscle endurance and then cardiorespiratory endurance and talk about these individually. I briefly touched on them here, but we'll spend more time on them in the next video.